In this lesson, we're going to take a look at how you can solve exponential equations that have the same base. Let's start by looking at the type of problem you might see. Example 1. Same base, variable in the exponent. Suppose we're given the equation 5 raised to the 3x minus 2 equals 5 raised to the x plus 4. Notice right away that the variable x is in the exponent on both sides. And just as importantly, the bases are the same. When two exponential expressions have the same base and they're equal to each other, then the exponents must also be equal. So we can set the exponents equal. 3x minus 2 equals x plus 4. Now we just solve this like a normal linear equation. Subtract x from both sides. 2x minus 2 equals 4. Add 2 to both sides. 2x equals 6. Divide by 2, x equals 3. If you ever want to check your answer, you can substitute x equals 3 back into the original equation. On the left side, this becomes 5 to the power of 3 times 3 minus 2. On the right side, this becomes 5 to the power of 3 plus 4. Now simplify the exponents. 3 times 3 is 9, and 9 minus 2 is 7. Since 5 to the power of 7 equals 5 to the power of 7, the equation checks, and x equals 3 is the correct solution. Example 2. Bases are different, but can be rewritten. Now let's look at a problem where the bases are not the same at first. 9 raised to the x minus 1 equals 27 raised to 2x. Even though the bases are different, I notice that both 9 and 27 are powers of 3. So I rewrite each base. 9 is 3 squared. 27 is 3 cubed. Now rewrite the equation. 3 squared raised to the x minus 1 equals 3 cubed raised to 2x. Next, I apply the exponent rule that says when you raise a power to a power, you multiply the exponents. On the left, 3 raised to the 2x minus 2. On the right, 3 raised to the 6x. Now the bases are the same, so I set the exponents equal. 2x minus 2 equals 6x. Subtract 2x from both sides. Negative 2 equals 4x. Divide by 4. X equals negative 1/2. Example 3. Let's look at another example, this time involving a fraction. 1 over 32 raised to the x equals 2 raised to 5x plus 1. First, rewrite the fraction using exponents. 32 is 2 to the 5th power. So 1 over 32 becomes 2 to the negative 5. Now rewrite the equation. 2 to the negative 5 raised to x equals 2 raised to 5x plus 1. Next, multiply the exponents on the left. 2 raised to the negative 5x. Now both sides have base 2, so we set the exponents equal. Negative 5x equals 5x plus 1. Subtract 5x from both sides. Negative 10x equals 1. Divide by negative 10x equals negative 1/10. Example 4. 16 raised to x plus 2 equals 64 raised to 2x minus 1. Neither base matches yet, so we rewrite both using base 2. 16 is 2 to the 4th. 64 is 2 to the 6th. Rewrite the equation. 2 to the 4th raised to x plus 2 equals 2 to the 6th raised to 2x minus 1. Now multiply the exponents. Left side, 2 raised to the 4x plus 8. Right side, 2 raised to the 12x minus 6. Now the bases match, so we set the exponents equal. 4x plus 8 equals 12x minus 6. Subtract 4x from both sides. 8 equals 8x minus 6. Add 6 to both sides. 14 equals 8x. Divide by 8, x equals 7/8. So here's the main idea from this lesson. If the bases are the same, set the exponents equal. If the bases are different, rewrite them using a common base. Once the bases match, solve the resulting linear equation. In part 2 of solving exponential equations, we will focus on using logarithms to solve exponential equations. Thank you for watching, and please consider subscribing for more mathematics lessons.